Question 1. A potentiometer does not A. Measure the EMF of two cells. B. Measure the unknown temperature. C. Measure the cell internal resistance. D. Compare the EMF of two cells. Answer B. A potentiometer does not measure the unknown temperature. A potentiometer is helpful in measuring current, resistance, and EMF. A potentiometer does not measure the unknown temperature. Potentiometers are commonly used to control electrical devices such as volume controls on audio equipment. It is also used in speed control of fans. Question 2. The length of wire in the potentiometer is 100 cm with a resistance of 30 ohms. It is connected in series with a resistance of 20 ohms and an accumulator of EMF 8 volts having negligible internal resistance. 1.2 volts source balances it against the length L of the potentiometer wire. Calculate the length L of the wire. A. 30 cm. B. 35 cm. C. 20 cm. D. 25 cm. Answer: 25 cm. Question 3. A potentiometer has 5 wires and the balance is obtained in the second wire. If the balance is to be shifted to the fourth wire, the current should be reduced. A. True. B. False. Answer: true. When the balance has to be shifted to a higher length, the potential gradient should be reduced. This can be achieved by increasing the resistances, in series, with the potentiometer wire. This can thus be achieved by reducing the current flow in the circuit. Hence the above statement is true. Question 4. Which of the following is an application of the potentiometer? A. Compares two currents. B. Measures current. C. Measures internal resistance. D. Measures external resistance. Answer: C. Measures internal resistance. A potentiometer is a device used to measure the internal resistance in a circuit. It can also be used to measure the EMF, comparing the EMFs of cells and variable resistors. Question 5. What is the potential gradient? A. Reduction in potential per unit length of the wire. B. Reduction in potential per unit area of wire. C. Reduction in potential between the ends of the two wires. D. Potential at any one end of the wire. Answer: A. Reduction in potential per unit length of the wire. The fall in potential per unit length of the wire is called as the potential gradient. It is mathematically written as K is equal to V by L. Question 6. The potential gradient does not depend on A. Current flowing through the potentiometer. B. Area of cross-section. C. Specific resistance of the wire material. D. Resistance per unit area of the wire. Answer: D. Resistance per unit area of the wire. The potential gradient depends on the resistance per unit length of the wire and the cross-sectional area. The potential gradient has no relation to the resistance per unit area of the wire. Question 7. What is the effect on the null point if the radius of the potentiometric wire is doubled? A. Increases. B. Remains unchanged. C. Decreases. D. Increases and then decreases. Answer: C. Decreases. At balanced condition, E is equal to K into L, where E is equal to EMF. K is potential gradient. L is length of the potentiometric wire. Thus, EMF of the battery depends on the resistance. So when the radius of the wire is doubled, the resistance decreases due to inverse proportionality with the wire area. Thus the null point will decrease. Question 8. The potential gradient of a potentiometer is 3 mV per centimeter. It measures the potential difference across a resistance wire of 20 ohms. If the potentiometric wire length is 60 cm to get the null point, what is the current passing through the resistor? A. 11 mA. B. 10 mA. C. 9 mA. D. 8 mA. Answer: C. 9 mA. Question 9. Potentiometer cannot measure A. Capacity. B. Electric current. C. Potential. D. Resistance. Answer: A. Capacity. A potentiometer can measure the internal resistance, potential difference, and current. However, the capacity cannot be measured by the potentiometer. Question 10. If the same current is allowed to flow but the potentiometric wire length is increased, the sensitivity A does not change. B increases. C decreases. D becomes uncertain. Answer: B increases. The smallest potential difference the potentiometer can measure is its sensitivity. This is typically increased by increasing wire length or using a rheostat to reduce the current. Hence, the length of the wire is increased but the current allowed remains the same, sensitivity increases. Question 11. A potentiometer measures the EMF of a cell. At the null point, there is no current flow through A. Cell circuit, B. Main circuit, C. Both A and B, D. Potentiometric wire. Answer: A. Cell circuit. At the null point, the current flowing through the cell circuit will be 0. Question 12. A cell is balanced on a potentiometric wire when the balancing length is 125 cm. Calculate the internal resistance if the resistance of 2 ohms is connected with a balancing length of 100 cm. A 0.25 ohms, B 0.5 ohms, C 0.05 ohms, D 5 ohms. Answer: B 0.5 ohms.
രംഗച്ചേട്ടൻ കാണിക്കും എന്ന് പറഞ്ഞാൽ കാണിക്കും. അമ്പാൻ തുറസി